Hello and welcome to Monday's edition of Cracking the Cryptic, and on screen today we've got a puzzle by Greg Dyer, and this has been recommended to us by our Discord channel, and it has also appeared on Logic Masters Germany, where it's got a whopping rating, 97% approval. So this should be a lot of fun, hopefully not monstrously difficult after yesterday's puzzle, which resulted in a very long video. Now, yesterday actually as well, we released a very popular series of tweets dealing with this, which is a picture from the sort of taken out of the new Batman trailer, and it's a riddle posed by the Riddler, and it reads, what does a liar do when he's dead? And what you have to do is you have to decipher these symbols you can see on the screen here to get the answer. So it's a word puzzle which is right up our street, and we had a few requests to solve it, so we released a series of tweets showing you how to do it. You can see these are the sort of the symbols translated into numbers. So what you need to do is to work out what the letter equivalent would be of each of these numbers in order to work out the answer to the riddle. So do check out our Twitter feed if you'd like to know how to do that. It's at Cryptic Cracking, and yeah, it's, as I say, quite a clever riddle for a Hollywood movie. Anyway, now the other thing that's been going on is many of you have been asking when I'm going to extract some measure of revenge on Mark for his continuing practice of sending me puzzles which he says are quite approachable, and they turn out to be like trying to win the Tour de France on a tricycle. Well, tonight's video, let's just say it features a puzzle for Mark that I've been saving up for him. It's a Japanese sums puzzle, and yes, it's the hardest Japanese sums puzzle I have ever seen. I've not seen Mark's attempt yet, but I have seen the length of the video that he's uploaded for tonight's bonus content, and the length of the video made me smile. So yeah, I hope that you'll enjoy that as much as I'm going to enjoy that. Now, what are the rules for Greg's puzzle? Let's talk about those. What we've got is normal Sudoku rules apply. In addition, difference and ratio clues are given. So adjacent cells whose digits are a multiple of one another are marked with a grey circle, the ratio of which is given inside the circle. Adjacent cells whose digits are different by a certain amount are given by a white circle, the difference of which is inside the circle. Not all possible white and grey circles have been given. Numbers have been replaced by letters A to J, not including I, obviously, which represent the numbers 1 to 9. No number is represented by more than one letter. So this is a very appropriate puzzle given our Riddler challenge, where we had to decipher or decrypt a code. We are going to have to do some decrypting in order to work out how Greg's puzzle works. You can see we just have a load of letters in this grid and some grey and white cells. So do have a go. The way to play, as usual, is to click the link under the video, and that means I get to have a go. Let's get cracking and see how we would solve the puzzle. That is the question. What should we do next? Well, this is obviously a variant on Kropki. Kropki often features black and white dots, and the black dots are always more useful. So I'm tempted to start here. We've got two G's in this box. Okay, so we can limit the value of G, because G, one of these boxes, even if I put a 1 in one of the boxes, the other box will need to contain a minimum value of 2. It might contain a higher value than 2, but it will have to contain a minimum value of 2, because even if I put the 2 there, obviously this square would then be a minimum value of 3. So the best I can do is make this square a minimum value of 2. Now that means that G cannot be 5, because if G is 5, obviously this square would have to contain a 10, because it's we have to have 5 times one of the digits being equal to the other digit. So if G can't be as much as 5, G has got to be 2, 3, or 4. It can't be 1, that should be fairly obvious, because that would just mean we have to repeat a digit in the cage, and we're not going to be doing that. So we are off with a bit of a restriction on G. Now G makes appearances in white cells, but not... no, hang on, H. Oh, no, actually, look at this. We've got H and F also appear in the same boxes. So H works exactly the same way as G, in the sense it can only be 2, 3, or 4. And similarly for F, it works the same way, even though it's not in a symmetrical position. Obviously, in these two dominoes here, we're not going to be able to have F being a 5. So actually, look at that. We get a 2, 3, 4 triple on G, F, and H. Okay, what does that mean? Be quite useful if there were... Oh, I tell you what it does mean. It means A, C, D, J. There's another C and J there. It means all of these can't be 2, 3, and 4. And they can't be 1, because 1 would then repeat in either a row, column, or box. So A, C, D, and J are 5, 6, 7, 8, or 9. So one of B and E has got to equal a 1. And remember, but we don't... I was wondering whether, because if B or E had been a greyed clue, we would have known the answer, but actually I've already identified all the grey clues. B and E both make appearances in white clues. So... this row is a little bit restricted. Look, we've got 2 Fs and 1 H. The problem is, without knowing what even... I mean, I may know that F and H are 2, 3, or 4, but without knowing the order, there seems to be a lot of ways this could work. G coming off this one. I don't like the feel of this. I think there's something more that we need to... I need to work out. I can't possibly have to pencil mark all of these, do I? No, one thing I can do. One thing we... yeah, okay, look. A, C, D, and J are all 5 or larger. Now that's interesting, look, because that means that there must be a 1 in all of those dominoes. Because if we put a 2 in, obviously we're going to break the bank. Now this is suspicious, because look, these 1s align. So that means, where do we put a 1 in row 3 of the grid? Well, it's got to be in one of those 3 squares, because it can't be here and it can't be here. So 1 is in one of those squares. Same down here, 1 is in one of these squares, because it can't be in any of those 6 squares. Now, in fact, J is another of these digits that needs a 1, because J is 5, 6, 7, 8, or 9. So this is a 1. And what that's attaching to an A as well. And C is symmetrical. C also needs to have a 1 on it because it's too big. So that must go here because it can't go there. There's already a 1 in this box. So we have got digits. There's a 1 in one of those squares by Sudoku now. And A... well, A can't be 9 now because... in fact, A could never have been 9 because A appears in a white box, and anything that appears in a white box can't be a 9, because if you put a 1, the other digit would have to be a 10. So in fact, maybe does C, D, or J appear in white boxes? No. Obviously quite deliberately. Okay. So what have these ones told us about the solve? They've told us that H and G can't have a 1 in there. That is important. That is important, of course. Because if G or H was equal to 4, you would need to have a 1 in one of the dominoes. Because obviously one of them could be 2 and 8. But if you try and put 3 in the next one, you can't put 12 in there. Look. The computer won't even let me put 12 in there. It just doesn't allow it because you can't put 12 in a Sudoku. So G and H, well, to put it another way, the clue that is equal to 4 needs to have 1 in one of its domino positions. Therefore, G and H are not 4. Therefore, F must be 4. Therefore, so now that can't be a 1 because we know 1 must appear in the dominoes. So one of these is 1, 4 and the other one is 2, 8. But we know the 1s don't go that side. So we know the 4s don't go this side. Okay, well this feels like progress. I've shut my window today, by the way, so it shouldn't sound like there's an air show going on outside. I do not know what is going on at the local aerodrome, but it is clearly noisier than usual. Okay, so now we've got F. Now, look, F makes an appearance here. So that has to be 5. Sorry, that's just been sitting there. So if that's 5, this F. Oh no, actually that's not that restricted because even with a difference of 4, I think there are 3 options there. So what are the options for G then? If G was 3, then we'd have to have 2, 6 in one of these. Actually, let's label them all up. We'd have to have 2, 6 would be one option, 2 times 3, and we'd have to have 3, 9 as the other option. And that's the only option. So if G is 3, that would be how this has to look. And that... well, it's not that helpful, but let's have a look at so if G was 3, H would be 2, and we know that it might be the other way around, but I just want to have a look and see what this looks like. So we can't use 1, so 2, 4 would be one option. There are 3 options here. 3, 6 and 4, 8 would be another option. So that is a little bit interesting though. So I've not managed to put 7 into this column yet. So 7 must be in one of those 2 squares. The other thing is there's always a 6 in one of these squares. Yeah, there's always a 6. That's interesting. So in the 3 clue, we're going to have to use 2 times 6 as one of the options. And in the 2 clue, you also need to use 3 and 6 as one of the options because the other option always uses a 4 because it's either 2, 4 or it's 4, 8. So there is always a 6 in one of these. Now that means that can't be a 6, which means A can't be a 5. So the 2 one is either, there's always a 4, and there's always a 3 and a 6. Oh, I've got it. Look. you can't put the 3, 6 domino in this position, because if you do, what do you put there in the multiply by 3 option? You can't now put this one as 3, 9, the 3's gone, and you can't put it as 2, 6 because the 6 is gone. That's very clever. That is very clever. So that means that, and it doesn't matter obviously which way round this is, because if we shift the 3 clue down here and the 2 clue was up here, we're still saying we can't put the 3, 6 option and the 2 clue in there, because it would just break. It's just symmetrical. It breaks the other way round. Now, what does all this mean therefore? So if on the hypothesis this is the 2 clue, we know the 3, 6 would be this side, and there would be a 4 in one of those 2 positions. And this 4 would accompany a 2 or an 8, which gives us, that's interesting, look at that, all the powers of 2, 2 to the 0, 2 to the 1, 2 to the 2 and 2 to the 3 are appearing in those 4 cells. So this one, this is fascinating. This can't be a 2, 6 pair then. So now, whichever way round this goes, we actually know, we know 6 of the digits. We don't know where they go exactly, but we do know that these yellow squares contain the digits 1, 2, 3, 4, 8 and 9, which means we've not placed 6 and 7, so 6 and 7 must go in those 2 squares. And this can't be 6, we've already said that, because there's definitely a 6 in one of these squares, on both sides, however you do it. So this has to be 7, which means A is equal to 6. Blimey. And that means that middle square is a 6. So now what I've got to be careful about is not using, I'm going to highlight these squares because I mustn't use, it's fine to use logic that applies to column 5, but it's not going to be fine to use this to eliminate this side of the grid until I determine which of 2 and 3, G and H, are. So A is equal to 6. So that one is a 1, 6 pair, look. That's a little bit restricted. That's either got to be 2, 7... Sorry, 2, 8 or 3, 9. But 6, look, 6 appears in row 8 and 9 there, and in row 8 and 9 here. And even if, this is gorgeous, even if this is not the multiply by 2 clue, and it's the multiply by 3 clue, there would still be a 6 in this foursome. And it still would be over here, but that makes no difference to the Sudoku logic I want to use, which is to say there must be a 6, or there can't be a 6, sorry, in those 3 squares, and there can't be a 6 in those 3 squares. So there must be a 6 in these 3 squares. And this is a multiply clue. And A has gone, so C can't also be 6, so there is no 6 there. There is a 6 in the F clue. And F is 4. So you can't accompany the 6 with a 10, so it's a 2, 6 pair. Oh, and that means this A clue is not 2 and 8, it's 3 and 9. And now we're going to get H, because look, we've not pencil marked in 4, 7 and 8 into the row. But this one has to have a difference of either 2 or 3, so it has to be 3. We have to use the 4, and we have to use the 7. Oh, this is gorgeous. And we're going to get C as well, so C is 8. C is 8. H is 3. G is 2. Now if 8... Oh, so this is the wrong way round. That's annoying. So, okay, so what I've got to do is I've got to move this 3, 6 over to there. What's the best way of doing this so I'm not going to mess it up? The 3, 9 has to come down there. Let's do that first. The 2, 4, 8 goes up here. Those two squares therefore have to be 3 and 6. These two squares are 2 and 6. So let's just double check now. So h is 3. I've got to multiply by 3 there, multiply by 3 there, multiply by 2, but I don't know which way round this is. I definitely know there's a 4 in one of those squares, and multiply by 2 here. So we're all good. Okay. Tidy up pencil marks and carry on. We can... So we can remove 8s from those squares. Still got to find 1, haven't I? Ah, look at that. G is attached to a 2 or a 6 here, and G is a 2. So this square is a 4 or an 8, but it doesn't tell us what that one is. Okay. These 3 squares, though, are a 4, 7, 8 triple, because obviously we've not placed those digits in the box. So so that has to be a 2. And if that's a 2, that has to be an 8, because f is 4. So this has to be a 1, and this has to be a 4, and this has to be an 8, and this has to be a 6, and this has to be a 2. And we are cooking with the proverbial gas now. 8 can be removed as an option for this domino. So this is a 2, 4 pair. These squares have got to be 5, 8, 9, I think. 5, 8, 9. So those squares are 3, 7. These squares are 5, 9. H is 3, so this square is restricted. It's got to be 6, 5, 2, or it can't be 8 because of the 8 here. So 2, 5, or 6. Don't think that's being resolved. D, look, D is not resolved either. J is not resolved. Oh, no, J is not 7 though. Because if J was 7, it would have to put a 7 there, and we can't. So J is not 7. J is 5. This square is a 5 or a 9. But we don't know which. Bother. So this is a 1, 5 pair or a 1, 9 pair. We don't know which. One of B and E is a 1. So the options for B and E are 1, 5, 7 and 9, just because we've already found 2, 3, 4, 6 and 8. So well, B can obviously B can't be 9 and E can't be 9. That's just nonsense, because you can't have a white clue that has a 9. We've already looked at that. So this square, B can't be 7, because if B's 7, the only option for this square would be a 1, and there's already a 1 in the column. So B is not. So B is 5. Sorry, B is not. What am I doing? B is not 7. It's 1 or 5. So if B was 1, this would be 7 or 9, and if B was 5, this would have to be 3. And I don't think there's anything wrong with that. Maybe we can get something from this B. Oh, we can! Yes, we can. This must be deliberate again. Look at this. If we try and make B 5, what are the options for this square? It's got to be 8 or it's got to be 4, and it can be neither. So actually, we know that B is 1. B is 1. So B, that doesn't give us that. But it does mean It does mean that E is not 1, and it means that this square, it does resolve this square, because this can't be 9, because that would have to therefore be 8, and it can't be. So that square is a 3. Oh, this square now has to be a 2 or a 4, so it has to be a 2. That's a 9. G is a 2, so that's a 4. E is a 5 or a 7. It can't be a 7. E has to be a 5. So we are actually, I think, doing quite well here. And once this is a 5, J must be a 9 because it couldn't be a 7. And we've cracked the code. We get a 9 here. We get a 1-9 pair there. D must be a 1-7 pair. B is, that one's a 9 now because it can't be a 7. E was 5, so this must be 4. Okay, can we finish this off with some aplomb? I don't know. Where's going to be the easiest place to look to? That can't be a 9. H here, H was 3. Oh, maybe this column, look, we've got 2, 3 and 5 to place. 2, oh yeah, okay. So there's just Sudoku to do. Let's do some Sudoku. That's 4 and 7 into those two squares. If this is a 2 and H is equal to 3, this has to be a 5, so this is an 8. C, I must know what C is. I do. C is that's a 1-8 pair. So this column is restricted as well. Look, that's got to be 5, 6 and 7. 6 is here. We get this one as well. 6 here, 5, 7 pair at the bottom. Oh, this 5, 7 pair resolves this square. That's a 4. That's a 7. These two squares have got to be 2 and 8. There must be a way of resolving these dominoes in the bottom. Is it this B clue? I'm not sure what else it can be. So this B clue needs consideration. Yeah, okay, it is this B clue, because the B clue needs a difference of 1, so you can never put a 7 in there. So this is 4. We don't know what that is. But the 7 resolves the 7 and the 5, which resolves the 5 and the 3, and this gets us going. Look at this, 9, 1, 1, 6, misclick, 6, 2, 2, 8, 8 and 4, great. F was 4, wasn't it? And F can't be 1 or 2 now. This has to be a 3, 7. That's the only option left. It can't use 8 or 9. So this is a 3, 7 pair. These two squares might be gettable. Look, we need 3 and 4. Let's have a look at this, because we've got... this can't be 3. Because if it's 3, you have to put a 2 or a 4 in that square. And 2 and 4 are not available, because of course B is 1. So this is a 4. This becomes a 3 or a 5, which we don't resolve, but we do get that one on the other side. And G is 2, so this has got to be 5. It can't be 1. That 5 fixes that one, look. 3, 7 get placed. We still need 1 and 6 into those two positions, which I don't know the order of yet. I don't think I do anyway. That can't be 5. Actually, this might be restricted now, because H was 3, wasn't it? No, it's 2, yeah, it is restricted. So that's 6, that's 9, that's 5. We need 4, 8, and 9 into these squares. So 9 must go here. These are a 4, 8 pair. And by Sudoku, look, we need 2 and 5 over there. And actually that's really important, because without this 5 we would be a bit stuck here. With the 6 actually is helpful as well. 6, 3, 3, 7, 7, 1. In fact the 6 is very helpful. 8, 4, 4, 2, 5 here, 2 here. And we've done a lot of the grid now. And it looks like we're just left with having to do some Sudoku to finish this, I think. 8, 7 there, 9, 5 here. That should be a 1, 6, 5 just to complete that. This is a 1. We need 2 and 3 into those squares. You can see we can place them. These should be 6 and 7. And the check function won't work today because I had to make a bigger grid, so we had this table on the right hand side. So let me just take a stare at this for a second and see whether it looks like I've put 1 to 9 in every row, column and box. It looks good, I think. Lovely puzzle, Greg. Thank you very much for sending that in. And thanks to the guys on Discord for suggesting that we solved it as well. It really was very, very enjoyable. I hope you guys enjoyed it. Let us know in the comments as always, and do check out Mark's video later on tonight. See you soon on Cracking the Cryptic.